Let us continue with exercise 5C, question number 24. We have A1, A2, A3, AN, they are the AP. Then we have to prove that whatever given here is equal to n minus 1 by A1 by AN. So the first term is A1, second term A2. Common difference we can write A2 minus A1, A3 minus A2, an minus 1. So it will continue like that. So because here we have in the right hand side we want n minus 1. Okay, so that means we need to replace all those. So whatever given here, we know that common difference, if we divide up and down by common difference, then we can cancel. So in such a way that we put this, then one we leave it upside, one we multiply inside to each and every part. Okay, so that we do that d. So now in place of this d, we have a1, a2. So when we can replace a2 minus a1, we have 2 and 3. We can write a3 minus a2. Then here we have an minus 1, an, it will be an minus 1. Okay, down remain the same. Then if suppose we break the LCM, it will be a2 by a1 a2 minus a1 by a1 a2. Then here a3 a3 minus a2 by a2 a3. So like that we continue to break. So if we break like that here, we can cancel a2 we are left 1 by a1 a1 we are left 1 by a2 a3 1 by a2 1 by a3. So we will continue up to 1 by an minus 1 minus 1 by an. So here you see we get 1 by a1, we get only 1 by a2, 1 minus 1 plus, 1 by a3, 1 minus 1 plus. So as a result, all the term will be cancelled except the first term and the last term, because all are common. We have 1 plus 1 minus. So that means we can say 1 by d is 1 by a1 minus 1 by an. But here in the right hand side, what we want a1 by an. So let's take LCM again. So if we take LCM again, a1 by an, then it will be a1 an only. Both are different. Then here it will cross an minus a1. Then there an we can apply the formula, general formula, because we don't want an here, we want n. Okay, according to the right hand side. So we use general formula a1 plus n minus 1 whole d. So minus a1. Okay, this part is general formula. A1 minus a1 plus we can cancel. Then this d and d we can cancel. So we are left with n minus 1 a1 an, which is what the question wants us to prove. Then number 25, we have m times, that means m into m at term is equal to n into n at term. Then we need to show that m plus n at term, it is equal to 0. First term we don't know, we take it as a, common difference, let us take it as d. Then we start from what is given. We have m am by n an. Okay, m we put it outside, so am we can put here, general formula, but in place of n we have to put m. This side also same, n let remain outside, an we can put inside bracket. Okay, we use general formula. Then now we multiply m into a, m into this one, then n into a, n into this one. So what to do? Nothing common, so we can bring a one side, d one side, because we need to find a and d in order to get the other term. So here m a common, we take common, we are left with m minus n. Here we have d common, so n into n square, n into minus 1 minus n, m into m square, minus to minus plus m whole d. So n square and minus m square we can arrange, then minus n plus m there. Okay, we want only a, so m minus n, you bring it down. Here we have formula n square minus m square. Apply the formula. We have a minus b, a plus b. Then we can take common minus. We get n minus m. N minus m, n minus m. Okay, we can take common. So we are left with n plus m minus 1. Then here we have m minus n, n minus m. So that we can cancel. Take common minus from here. Okay, so m become plus, then n become minus, so it can be cancelled. Value of a is minus n plus m minus nd. Now we want to find a m plus n, so apply general form, but in place of n we have to write m plus n. Then a we already have from here. Okay, then with this one, so if you compare m n minus 1 minus 1, they are same, but this one is plus sign, this one is minus sign. As a result, it become equal to 0, which prove the equation. So with that, 5C is complete. So we finish to use the general term. Next we have to find the sum. So if we compile those several term, then we will come to the using general term, then we will come to the formula, which we get n by 2, 2a plus n minus 1 whole d, if we know the first term and the common difference. Or if here we rearrange this formula, then it will come as Sn, S stand for sum, okay, n number of term, then it will be first term plus last term. Last term you can write it as an, or if you write l also, it's the same. So excess there. Okay, here you can see how we get the formula. So you see like first term plus second plus third. Okay, those, then a. So if we calculate it like that, then it will come to the formula. But derivation you don't need it here, you only need, okay, so from where it come from the general term only when we plus them. So if we take common and all, it will come here. Now you see they say find the sum of the given APs. So these are AP already. Then you look at this last one. If there is TH, that means the given number is n. Okay, then here they have terms, so clearly that means n is n. Here n is 81, here n is 100. First term you know 5, second term you know 2. You can easily find the common difference. Common difference is second term minus first term. So 2 minus 5, it will be equal to minus 3. So since we have to find the sum, let us use the formula Sn. We know the first term, we know common difference. So we can use the second formula, okay, n by 2, 2a plus n minus 1d. N here is n, but a we have 5, so that we can replace. N we cannot replace, then d again we have minus 3. 2 into 5, 10, minus to plus minus, 3 into n, minus minus plus 3 into 1. So 10 plus 3, we have 13 minus 3n, okay. After that we cannot plus, we cannot minus, that is the answer. Then here we have again, now we have 81 terms, so that means n equal 81. First term we have minus 1, then the second term 1 by 4. So you can find the common difference. But here we have 1 minus from formula, 1 minus from question. So you better multiply them, become plus. Once you have fraction, you please find the LCM. Then 1 divide 4, 4, 4 into 1, 4. So common difference is 5 by 4. Then we can use the formula. In place of n, we put 81 wherever there is n. Then a, the first term, we have minus 1. The common difference, we have it 5 by 4. Here, because both are number, we can minus. 2 into minus 1 minus 2 80 minus 1 will be 80. So 4 divided 80, 20. 20 into 500. 100 minus 2, we get 98. Now, since we have multiply, we can divide. So 98 divided by 2, we get 49. You multiply, then the sum is 3969. So the same way, you can try yourself number 3 and number 4. Then number 5 also, we have n equal 22. Then the first term we take x plus y, second term x minus y. Let us find the common difference. Then here minus into inside. So 1x is minus, 1x is plus, we can cancel. Y both minus, we can plus, but sign remains same. So this will be a common difference. We have to find the sum, so let's use the Sn. N already given 22. A we get x plus y. D we get minus 2y. N we know 22. So here both number we can minus. 22 minus 1 will be 21, minus 2 plus minus, then 21 into 2, 42y. 2 into x, 2 into y. So 2x, we cannot do anything, leave it there. 42 minus 2 will be 40. This is minus, we can, because it's greater, those. Then here we have 40 and 2. Even number, we can take 2, take common outside, okay? So 2 into 11, 22. Here we cannot minus, we cannot plus, so we leave that as the answer.